Good morning, everybody. It is Thursday, June 4th, and for those of you who might need to do a retake on the Chapter 9 test, I have another review. We're going to go over some of the problems that you may have struggled with, and then following this is the retake. If you have checked your grade and you do not need to do a retake, congratulations. Unless you have missing assignments that you need to work on, you are done for the year. Congratulations. We're sorry that we can't say goodbye to you in person, but this is the way it is this year. So best of luck to you next year. Work hard, you're going to do great. To begin with, we have the parallel lines crossed by a transversal line that we want to review those different types of angles. And one of the things that we really need to pay attention to is the location of the angles based on where they are compared to the parallel lines and compared to that transversal line that cuts across the two parallel lines. So to begin with, we have lines or angles that are going to be on the interior of our parallel lines, angles that will be on the exterior of our parallel lines. We might have angles that are always on top of the parallel line. We might have angles that are always on the bottom of our parallel lines. But those are things that you want to pay attention to. Where are they in relationship to the parallel lines? The second thing that you want to pay attention to is where are those angles in relationship to the transversal? So all of these blue arcs are showing us angles that are on the right side of our transversal. That means they're all on the same side. They're all on the right. On this side, we have angles that are all on the left side of the transversal. We refer to all of those as same side angles. And then we have ones that are considered on alternate sides. This blue angle is on the left, this one's on the right. So instead of calling those opposite sides of the transversal, we refer to them as alternate sides. This purple one, one's on the right, one's on the left. Those are alternate sides. Same thing with these two green and these two blue. One's on the left, one's on the right. Those are alternate side angles. So going back to the different types of angles that we have corresponding angles. Those are angles in the same locations, and I'll show you what that means. We have vertical angles. Those are formed by two intersecting lines. We have same side interior and same side exterior. We have alternate interior and alternate exterior angles. And I saved myself some time by not typing angles each time, so I will fill that in now. Okay, so corresponding angles. Corresponding angles are both in the same location compared to our parallel lines. Corresponding angles are either both on the top right, so they're both above the parallel lines and to the right side of our transversal, or they're both on the top left of our parallel lines we could have bottom left of our parallel lines or bottom right. But in every case, they're always in the same location compared to the transversal and the two parallel lines. Vertical angles. Vertical angles are formed by two intersecting lines. They don't have to be parallel lines. You don't even have to have three lines at all. You just need two intersecting lines. So if I just take my transversal and one of the parallel lines, vertical angles form a V and are the same size. So here's one V, here's another V. Those are the exact same angles, and they basically share a point. Because my lines are so wide, you can't really see that, but they share the same vertex point. The same thing applies with these two angles. We have a V here and a V here. They're the same size. They're across from each other. So those are vertical angles. We have same side interior angles. So same side interior angles means that they're inside our parallel lines and they're on the same side of the transversal. So if I pick one of my angles inside the parallel lines, this is the other angle that's on the same side and inside the parallel lines. If I choose angles on the right side, this angle's inside the parallel lines, inside the parallel lines. And what's significant about same side angles when they're interior or exterior is they're not equal to each other. Same side interior angles will actually add up to 180. The same thing applies when we're talking about same side exterior angles. Here's an exterior angle. Here's the exterior angle. They're on the same side of the transversal, but they're both in the exterior section of our parallel lines. Our blue one, we have exterior on the right side, exterior on the right side. Those are same side exterior angles. Going to alternate interior and exterior angles. So interior angles, I'm going to pick an angle on the inside of my parallel lines, and I want alternate interior, so I'm going to do the angle on the opposite side that's the exact same size. Okay, alternate interior angles are always equal. So these are alternate interior angles because they are equal to each other and they're inside the parallel lines. We can do this angle on one side, it's on the right, on the other one, it's on the left. They're both inside the parallel lines and they are equal to each other. We can do the same thing with the exterior angles. When I choose the exterior angle on the top right, then I'm going to go to the bottom left. I'm going to get rid of that. Same thing with this angle. If I choose an exterior angle on the left, then I'm going to choose the right side angle for the alternate exterior angle. So we're going to put over here, corresponding angles are always equal to each other. Vertical angles are equal to each other. Alternate interior angles are always equal. Alternate exterior angles are always equal. Same side interior and exterior angles add up to 180. They are not the same size. Moving on to the next topic, we know that all the angles in a triangle always add up to 180 degrees. It doesn't matter what type of triangle it is, this always works. So if I have two angles that are 70 degrees and I'm missing this angle, if I add 70 plus 70, I get 140 degrees that's already been used. I have 180 degrees altogether. So if you subtract the angles that have already been used, we're left with 40 degrees for our last angle. And that works for all triangles. Same thing here. If I add 60 plus 110, I get 170. What's left if from 180, if I've already used 170, 180 minus 170 is 10. And the last one appears as though we don't know two of the angles, but whenever we have that square in the corner, we know that that's 90. So 90 plus 138 is 128. If I subtract that from the 180, borrow a 10 from the 80, 10 minus 8 is 2, 70 minus 20 is 50, and 100 minus the 100 is gone. So this is 52 degrees. You just add up the two angles that you already knew and then subtract that from 180 to get your third angle. In the next one, it said, determine if the three side lengths create a triangle, and if they do, what kind of triangle is it? So if we have three side lengths, those appear like they're going to make a triangle. I can make a very dramatic example. Will these three side lengths create a triangle? And in that one, no, they won't. These two are too short. So what is it about these lengths that will actually allow them to connect? And what we need to have happen is for this short length and this shorter length to be long enough that when we extend them, they're going to be longer than that bottom side. So my two shorter lengths, the two shorter lengths added together must be more than the longest length. If they're not going to make a triangle, we can't figure out what kind of a triangle because it's not a triangle. It's a moot point. So if we know that three sides will make a triangle, we need to identify the type of triangle. And we discovered that if you square the sides of our triangle and you add the two smaller ones together, it will always equal the largest square. We're not talking about adding the short two legs together to equal the hypotenuse. The legs are the two shorter sides. Hypotenuse is always the longest. The legs will also be the ones that make up that right angle. You need to square them. And if you think about that short video we had where we had the water that filled up the two smaller squares, and when they rotated the diagram, all the water filled up the largest square? That's one of our proofs of why the two legs squared added together equals the hypotenuse squared. So, what about acute and obtuse triangles? So if I take this situation and instead of having this right angle, I'm going to take this side and rotate it in. When I do that, when I rotate it, this top angle gets smaller, this one gets smaller. What happens to our largest square? It doesn't need to be as long as it was before. So that's going to shrink c squared. C squared is now going to be smaller. A squared and B squared are not changing at all. But C squared only needs to come out to here. That's going to make it a smaller square. So if C squared is smaller than your A squared and B squared, we know we have an acute triangle. We can do the same thing with what happens if we rotate it and make our right angle larger. Now we have an obtuse angle right here. If I try to rotate this to connect out here to make my hypotenuse, which is no longer a hypotenuse because it's not a right triangle, but this square needs to become larger. The only way that's going to happen is for c squared to get bigger. And if the c side gets bigger, c squared is getting larger. So therefore, obtuse triangles occur when c squared is larger. When we started using the Pythagorean theorem, which says a squared plus b squared equals c squared, we had some problems where we actually demonstrated that. We tried to figure out, okay, so what's this largest square? And on the test, I had several people that just added these two sides together. Remember, it's not the sides that add together. These two sides added together have to be more than that side to even make a triangle. We have to square the sides. So if the side length is 8, 8 squared is 8 times 8. So this would be 64 inches squared. Remember, you're multiplying it by itself. 8 inches times 8 inches is 64 inches squared. To do the same thing here, 20 inches times 20 inches is 400 inches squared. That's what the whole area of the square is. And then we add these two smaller squares together to get the largest square, which gives us 464 inches squared. That only addresses the squares of the legs. Once we know what the squares are, if we don't know a side length, we can always go backward. For instance, here, the square root of 64, what do we multiply by itself to get 64? It's 8. Makes sense because that's what we started with. If we go to 400 and we do the square root, we get 20. Makes sense because that's what we started with. If I take 464 and I take the square root I don't get an exact value. I get the number 21.54065922853802. It's going to go on forever and ever and ever. So we will always tell you, what should you round it to? We've been telling you to round to the nearest tenth. So that means we want to know, is this closer to 21.5? Or, because it's actually more than that, should we round to 21.5 or 21.6? People did much better on the test with their rounding, but we still want to kind of review this. If this number here is larger, 5 or larger, then we're going to round it up. If it's less than 5, then we're just going to cut that off. In this case, our answer would be 21.5. That's a reasonable answer considering we had sides of 8 and 20. And when we add them, when we put in our 21.5, 8 plus 20 is larger than that, and this is the largest side. We're going to do a couple more examples like that. So here we have a right triangle in both cases. So we're just going to find the length of the hypotenuse. We can't do that without finding the squares. So we do a 5 squared, we do the 12 squared, and when we add those together, we get the square out here. So 5 squared plus 12 squared equals x squared. 5 squared is 25. If it makes more sense for you to put it in the actual squares, that's fine. 12 squared is 144. Add those two together, we get 169. But that's for the whole square. We want to know what the side length is. So we're going to take the square root of 169, and the square root of 169 is 13. 13, once again, is a reasonable answer because 5 plus 12 is more than 13, and 13 is the largest side. Now we're going to do the same thing over here. I'm going to switch color. So we start with our 7 squared and our 9 squared. And I'm not going to draw over my writing this time. And that's going to equal our y squared. So 7 squared plus 9 squared is y squared. 7 squared is the same thing as 49. 9 squared is equal to 81. When we add those together, we get 130. But that's for the whole square. We want just the side length. So we're going to do the square root of 130. And the square root of 130 is not an exact value. It goes 11.40175 on and on and on forever and ever. So we're going to have to round this one like we did on the page before. We're going to round to the nearest tenth. The next number is less than 5, so we're going to cut that off, and we're going to write our answer as 11.4. I'll just get that out of there. Again, that seems like a reasonable answer because our original sides were 7 and 9. 9 plus 7 is more than 11.4, but 11.4 is still our largest side. Go ahead, take your time. If you need to go back and take some notes, write things down, that's perfectly fine. We want you to do your best on this test. go ahead and complete the problems. And then that is the end of your 8th grade math career. Again, if you have any missing assignments, you can still turn those in between now and Monday night. Have a good summer, everybody.